Today, we're going to talk about graphene in medicine. Graphene is a laminate material composed only by carbon atoms organized in a hexagonal shape. There are a lot of applications in industries due it has a high hardness and has light weight. It comes to weight 0.77 milligrams per square meter. That's why it's used in buildings, construction, bulletproof vests, even is used in aeronautic industry because of its properties. Graphene is used in isolation, but it must go through several processes that allow its safe and functional use in the body. This consists of its transformation, pegylated graphene oxide, and the subsequent addition of drugs, such as desoxyribosine in the center of the molecule of radiolabeling with 125I and adding antigen antibody complex style ligands of the surface. It is an antibacterial that puts an end to two bacteria with the greatest clinical problems. They are Escherichia coli and Staphylococcus aureus. According to studies, by putting a graphene film with copper, the constant transfer of electrons from the bacteria cell to graphene and later to copper result in an inability to breathe for both bacteria cell and loss of membrane potential, causing cell death.
Okay, for the characteristics, it has high electrical conductivity. This gives it the ability to easily pass for the flow electric current and give us lower power consumption, even less than silicon, for example. And for second, high hardness and resistance. It is a material that has resistance 200 times greater than steel, and that's why it's a very resistant material to wear and tear and can withstand heavy weights. Third, these have high flexibility and elasticity. This gives us a material that can be molded many ways, and that in turn thanks to to this elasticity increase the durability and hardly break. And for the last, have a lightweight, like materials with high hardness. This one does not weigh much, which gives it a high versatility in its uses.
Application of graphene in medicine. Creation of neural implants that constitute the make organic tissues with graphene. The bonds between the molecules are strong aspect that guides stability to the compound and could have other important use. Totally removed from consumer technology, the properties of graphene make it an ideal candidate for the creation of this type of implants, being able to be a replacer for injured nerve circuits or even creating retinal implants that help restore signs to patients who have lost it, including for people. One of the experiments relates to device made of graphene that can interact with the fluids that surrounds it. In this way, the prosthesis will work by lining of the every month. Continue. The most outstanding thing that researchers have discovered is that its use is not only limited to the generation of nervous tissues, but there is already speculation about the possibility of creating muscle bone implant from this material. Continue. One of experiments related to device made of graphene that can interact with the fluids that surround it. Uh, in this way, the processes will work by linear on the every moment. To check this probability of graphene, the team of scientists at the Technical University of Munich has been doing tests on the ganglion cell of the retina, a type of nerve location on the inside of this membrane. The results have been excellent.
Graphene as a cancer treatment. Cancer is one of the leading causes of death in world, and scientists are looking for an efficient treatment to heal this disease. As we can see in the picture, cancer is take 13 lives in the world. So this is very important for the scientists and the world. So they decide to looking for a material that can help in this disease. This is what the graphene comes. The graphene has a property to absorb the infrared lights, the same used in radiotherapy. This helps the ray to focus on the affected cells, and this process helps decreasing the side effects caused by the radiation. In the experimentation, this treatment proved to be efficient in 6 kinds of cancer: breast, pancreas, lung, brain, ovaries, and prostate. This treatment is still tested to check its effectiveness. Thank you.
Carbon nanotube as an antibiotic. Carbon nanotubes are rolled graphene sheets that form a cylindrical piece with a diameter close to 1 millimeter, and depending on how the graphene sheet is rolled, they can have metallic or semiconductor properties. In a study which pegylated carbon nanotubes were used for the first time, a layer of silver was added in an attempt to eliminate the pathogen Salmonella typhimurium, which has a considerable resistance to the traditional antibiotic therapy that cause clinical problems. Previously, a study have showed that silver nanotubes had great antibiotic potential, but the toxicity levels against human cells raised concerns about their safety. However, in this study, it was possible to demonstrate the safety of the use of pegylated silver nanotube, and also making use of three cell lines: pulmonary, hepatocellular, and macrophage, and sufficient MIC values were obtained to cause bacterial death by damaging the membrane, creating of radioactive species, and elimination of cellular content without causing any damage to human cells. Thank you.